Hi everyone. So today we're going to look into the topic of this artificial rainfall. So it is what it actually sounds like that we are going to artificially make the clouds rain, right? So let's dive into it. So what we'll be looking at today is first we'll see what is this artificial rainfall and why do we need it, and what is the history of this artificial rainfall. Another technical term for artificial rainfall is this cloud seeding. So we'll look into the history. Then we'll see what are the traditional methods that we have been using in the past to make artificial rainfall, and then we'll see what are the limitations and risks of playing with the nature. And then go ahead and look into some of the advanced techniques that are being used in today's world. And we'll conclude our presentation by looking at the environmental and ethical concerns and the future actions that we can go ahead and look at. So moving on. So why artificial rainfall and what is it? So basically, what happens is that you may have clouds in the environment around you, and those clouds do not always rain, right? So we somehow know that if the cloud is darker, more grayish, more blackish, it's going to rain. But if the cloud is looking with white color, it has some remembrance of the white uh, shady color, then probably it's not going to rain. Okay. So what are clouds? Clouds are basically just water vapors. Okay. So it's just humidity, it's just water vapors, and when light comes uh, through those water vapors, it reflects back and it shows us different types of colors, right? So it could be white, it could be grayish, it could be very black, near to black. So what happens is that if there is less concentration of water, then we may see less concentration of water vapors in the sky, then we may see a white color of light because that's the reflected light from those water vapors. If there are a lot of water vapors, we may see a grayish color. If there is a huge amount of water vapors in the sky at some very close by distance, we will see some blackish clouds, and it mostly rains when it's grayish. So when it's already raining, then we do not need to create artificial rainfall, right? Because it's already raining. But if there is some places where there's no water and there's scarcity, drought, and there's heat wave, and the temperature is hot, and we do have some white clouds around, what we can do is make those white clouds rain. They that wouldn't rain on their own. Okay. So what we do is we take some kind of drone, an aeroplane or whatsoever, and spray a special kind of chemical to these clouds on top of these clouds. That chemical causes that less amount of water vapors to drop to the ground. Okay. So what happens is that you have water vapors, and if they are far away from each other, if they're far away from each other, you're going to see a whitish type of cloud. Okay. If the mass of individual water vapor is larger, it will fall towards the ground. If it is lighter, it will hover in space. Okay. So in these white clouds where no rainfall is going to occur, there are very small, tiny particles, tiny water vapors that are far away from each other. And because they are so small that their mass is not large enough for them to fall because of the gravity. So what these chemicals do is that when we spray them onto the clouds, when we spray them onto these clouds, what happens is that they act like a magnet. Okay. So when these chemical particles go into the cloud, they attract the nearby water vapors like a magnet. So when water vapors are attracted, when they touch each other, it becomes the larger water droplet. Previously, it was many, many, many small water vapors of less mass Now, after spraying this chemical, what happens is that now all those small tiny particles join together and become a large water droplet, which under the influence of the gravity falls to the ground and we see, yeah, it's raining. So that happens in the clouds where water droplets are very, very small and they're far away from each other that they cannot join onto of each other. In those grayish and blackish clouds, this process is occurring naturally. Okay. So two clouds, you might have heard about how does rain occurs. Two clouds meet each other, then rain occurs. When if there's a lot of water vapors and they are good enough in size, they are larger, and when they hit each other, they'll become much more larger. And because of their increased size and the influence of gravity, they fall to the ground. And we say, well, it's raining. So if this process is not acting naturally, well, we make it rain using this chemical. So this is basically called the cloud seeding. Okay. So we are seeding the clouds. That seeding is the chemical agent. So why do we need it? We do understand that we have a global challenge of water scarcity, and there are about 2.3 billion people who face water stress. And we can observe, well, not this year, but previously we have been observing that there are a lot of droughts, heat waves, erratic rainfall throughout the world in different parts, and we do have a lot of hot weather in some parts of the planet. And in those parts, we have the risk for agriculture and food security because if there is no rainfall, there's no water, there's no crops, no food, and people find it difficult to live there, right? So, artificial rainfall is a tool for resilience. Okay, so now let's have a look at the natural rainfall cycle. So we do understand that we have clouds and there is rain, then rain comes to the back to the ground, from goes to the rivers to the sea. We have this water because of the heat, the water vapors go up to the environment, and once they have reached certain height, because of the cooling and height effect, they become clouds. And this process goes again and again. So clouds are nothing but water vapors. Okay. So when these water vapors are very, very small in size, that the gravity is not strong enough to pull them down, they remain in the cloud. But if these water vapors increase in size due to whatever the reason, by colliding with the other water vapors naturally, or maybe because of that chemical that we added that acts as a magnet, when they increase in size, they drop to the ground. Okay. So these are the water vapors that make up this cloud. So we have this water vapor plus condensation nuclei. Okay. So this condensation nuclei is the technical term for that magnets that I've been referring to. Okay. So that chemical that we are spraying onto the clouds or anything else, anything that will make multiple, many small particles come towards a singular point is a condensation nuclei. So this condensation nuclei is actually the magnet. Normally, in the past, we have been using silver iodide chemical. Okay, silver iodide chemical to spray on the clouds, and silver iodide is a condensation nuclei. What is a condensation nuclei? It's just a magnet to attract water. So when we spray silver iodide on the clouds, those small tiny particles of silver iodide chemical, they act as condensation nuclei and they attract the water around them, and all of them joined together make a huge size water droplet that under the influence of the gravity falls to the ground along with that chemical. Okay, so that is why this is not a very uh, environment friendly method, because if you put the chemical to the clouds, that chemical is going to come to the ground as well. So silver iodide is not very friendly to the crops, not even humans. So we can't drink that water because that water would contain that chemical that we separate. So the chemical the rain will happen, but it would contain that chemical. Naturally, well, the water will attract the other droplet of water because of the natural collision of clouds. So natural rainfall water is great, but if you are going to make artificial rainfall, then that water is not for drinking or probably the agriculture purposes. However, we have made some amendments in the recent years to cater this issue. Now, somehow it is somewhat safer and sometimes more useful. We'll see how is it safer, when is it safer, and where is it more useful. So, so in the natural rainfall, as I explained, that droplets grow by collision and lessons. And when those water droplets, when collide to each other, they combine and make a larger water droplet, which is when heavy enough, it falls to the ground, and we call it that. Okay, yeah, there was rainfall, and depending on the temperature of the environment, it may snow or rain. Okay, because we are going to make that whatever was in the cloud come to the ground. Okay, so it depends on the temperature that whether it's going to be water that comes down, we would call it rain, or is it going to be snowfall that comes down? We will call it snowfall. Okay. So it's rainfall or snowfall. It depends on the temperature that surrounds you. Let's say if you are in some place with maybe 25, 30 degrees, okay, yeah, it's going to rain. But if you are at some point which is less than 0 degrees, maybe -1, 0 degrees, somewhere around that, so maybe you'll see this artificial snowfall, but usually we'll go ahead with artificial rainfall terminology. So not all clouds naturally produce rain. So that is the point that I was explaining previously, that there are a lot of clouds. They may look grayish or blackish, that have a lot of concentration of water, and they produce the rain naturally. But there are a lot of clouds of white color that do not produce that do not produce the rainfall. So we have to target those clouds. Okay, moving on. So cloud seeding, which is the artificial rainfall, which is this cloud seeding terminology is the same phenomena that we are going to spray the chemical on top of the clouds. So we use some kind of aeroplane, the drone or whatsoever to bring the chemical to the air, and we spray that chemical. Usually that is silver iodide, or we could use dry ice. There are different kinds of condensation nuclei, which is the magnet. So we can use various different kinds of magnets. There are a lot of things that can act as a magnet. Okay. So we can use them, spray them onto those white clouds, and that chemical will help in condensation of water vapors and formation of ice crystals, which are heavier in size and they will ultimately fall towards the ground. Okay, so cloud seeding is basically weather modification, right? So we're going towards the clouds to bring the stuff, and we are changing the weather because we're going to make it rain, which was not going to occur naturally. So it introduces particles or charges into the cloud. So at the moment, we are looking at this introducing the particles, which is chemicals, or charges into it. We'll go ahead and look into this charges into the cloud part a bit later, because this is one of the more advanced techniques that nowadays we are using, right? So we'll just hold on to this charges into the cloud part and look into it in a few minutes. So what happens is that accelerate droplets growth, which causes rainfall, snow, maybe fog. So what we can do is, since we can make those clouds uh, more heavier, which may cause rainfall, snowfall, maybe change the fog to water vapors. We can change the type of weather in the environment. So that can really do a good job, because we then can control flooding that is occurring in a lot of areas. How does flood occur, right? So what happens is that there's a huge amount of rainfall at a certain area, and because of some water streams and stuff like that, a lot of other parameters, we see a flood in some area was flooded. So how we can control is that problem is this, that we can make those clouds rain at different regions rather than a singular region. So, for example, if I live in a city and let's say in an hour, a lot of rainfall is going to occur in my city and there's going to be a flood. Now, I can predict the weather, right? Somehow we have the senses, we know what's going to happen. We can predict that it's going to rain in an hour, in a day, or in a week. So now I know that it's going to rain, a huge amount of water is going to come to my city. And I know from where the clouds are coming. I know that the clouds are coming from the east, from the west, or from whatsoever direction. So what I can do is, before they reach my city, I can go to those clouds, send a drone to those clouds, put the chemical there, and make it rain in the other city before it reaches my city. It was not going to rain naturally in the parallel city, maybe nearby city around me. It was not going to rain naturally in the other city, but due to my cloud seeding or weather modification technique, any kind of technique, I made it rain there. And there were clouds coming from the west. I made them rain somewhere else. There were clouds coming from the south, from the north. I made them rain at separate parts. So when the rain was at separate parts, there was no flood. The flood was going to occur when all of those clouds were going to combine at a single place and a lot of water was going to drop, right? So somehow we can use this technique to prevent floods as well. And we can, of course, use it for fog control as well, because fog is also, again, water vapor that are very near to the ground. And we can make it rain. When it rains, there's no fog, right? So it can enhance. This is the very important part, that we can only enhance but not create the precipitation, which is the rainfall, the water vapor. So we, for artificial rainfall, we need clouds. We cannot create clouds. If the clouds are weak on their own, then they do not have enough concentration of water in them to produce rain. We can make them rain in that lower concentration, but uh, we cannot make it rain somewhere where there is no clouds. Okay, so we are not creating clouds. We're just causing the clouds to rain forcefully sometimes. Okay, so I included a video here. I included a video here uh, that shows how an airplane is going to spray the chemical. Okay, so here the airplane was sending a lot of chemicals, and sometimes, yeah, cloud seeding does produce a lot of rain, and it is, well, mostly it is damaging. So we have areas like that, and we spray the chemical into the air like this. It combines with the cloud, and, well, yeah, we may overkill it. And there have been incidents that China tried to rainfall a lot of time, and well, there was a lot of rainfall that brought the flood on its own. So it must be controlled. You cannot just separate too much chemical into the air, because that may bring a lot of rain that might be uncontrollable for the people who are initiating it in the first place. So I have included a technical diagram of how the technology for this artificial rainfall can be tested in some lab before it can be deployed in the real environment, right? So yeah. So what we have here is that we have some electricity, and uh, we have some uh, metal point that is going to produce some sparks. So this is one of the latest techniques that is being used to create a artificial rainfall. So we understand the basic concept. That is, there are water vapors that are very, very small in size, and because they're very, very small, the weight of these small water vapors is not enough for the gravity to pull them towards the ground. So we have to introduce something so that those small water vapors come together, touch each other, and by touching, I mean join, combine together, and form a larger droplet. So a larger droplet will have more mass, and the gravity can pull it down towards the ground. So, what is the thing that we can use to make those small water droplets come together and join and make a water droplet? We, for now, as so far, we have seen chemical agents can do that job. Chemical agents can act as a magnet for the water vapors. And we saw the technical term for that, that was the condensation nuclei. Okay. So anything that attracts water can be considered the condensation nuclei in simple terms. So we have another technique. That condensation nuclear was a chemical, right? The chemical may be helpful for the ground that it falls on, or it might be dangerous. So you cannot bring silver iodide, right? So it is dangerous for you. So yeah, that's one method to make it rain, to make combine those water vapors. So is there another method that is a little bit more safer? Yes, there is. And that is the ionization. Okay. So what we do is that we give electric shocks to the cloud. Okay. So when I say we give electric shocks to the cloud, what it means is that there are water vapors and we are giving electric shocks to those water vapors. So when we give electric shocks to those water vapors, what happens is that it becomes ionized. What it means to become ionized is that we create, because of the electric shocks, okay, we create positive and negative charges onto those water vapors. So yeah, we do know that if there is something called positive, there is something called negative, well, they will attract each other and they will join. So by giving them electric shocks, we create charges on those water vapors, and because of those charges, they join together. Now there is no chemical being used, right? So we only created those charges. When positive charge met the negative charge, it became neutral, and yeah, so the water droplets combined made a larger water droplet, and there was no chemical involved. Now, when it falls to the ground, it's just like a natural rainfall. Okay, so how much electric shock and how strong it should be, we will design stuff like that. And we have this high voltage power supply that is connected to this point, which will have this corona discharge. Corona discharge is basically the sparks, right? You may have seen sparking or electric sparks of electricity, right? It's the lightning stuff. So we call it the corona discharge. The technical term for those sparks and lightning discharge is this corona discharge. We have some insulator because it's high voltage and we don't want to touch it. We don't want the charges to go somewhere else. We have that insulator, and we have this, well, there's vapor injection. Okay. So we have this vapor injection, which is the water vapor. So we inject the vapor. So we are creating an artificial cloud inside this chamber. So when we insert this water vapors at this point, so there is cloud here. So there's cloud here, but it's not raining somewhere. So when we give electric shocks, there are positive, negative charges, water droplets combine to each other, and we can observe that yes, indeed, there were droplets formed and they dropped to the ground. So that's a laboratory experiment that we can perform before going up to the sky, spending so much money. So for confirmation purposes, we do this in the lab. So along with this electric shock therapy or the method, what we can do is we can introduce that sieging agent as well. So to ensure, yeah, we did a great job because a cloud is a huge amount of air. Okay. So if you're going to give electrical shocks, well, it is very difficult that you cover all of that area because you have probably have seen the sparks. They're very small in size and they cover a limited amount of area. So, well, uh, it's very difficult that you can give the sparks to every inch of the cloud. Okay, so wherever you are supplying that spark, only that area is going to produce those positive and negative charges, and only that area is going to combine those waters. So to ensure that it does rain, okay, whenever we do, so what we do is along with this electric shocks, we introduce that old technique as well. We bring that seeding agent, the condensation nuclei. We separate the chemicals and give the shock to increase the probability of success, right? So it's not a guarantee that when we separate the agent, it's going to rain. Well, because we have otherwise we have to separate the whole cloud, right? So we have to ensure that we can combine as many water vapors together as possible to make it rain. So in nowadays, what we are using is this, the electric shocks along with that seeding therapy. Oh, sorry, not the therapy, the method, right? So moving. So traditional methods have been using the silver iodide, which is the most effective one, or sometimes the potassium iodide. Dry ice in itself is a water vapor, condensation nuclei, but we have to separate that. We have to separate, bring the dry ice into the sky and separate that dry ice. Okay, and then we have these hygroscopic salts, which is the sodium chloride, potassium chloride, magnesium salts. We can use them as the chemical agents as well. We can use the liquid propane, aircraft, rockets, and ground waste generators. All of them can be used for this artificial rain. So the way it works is that we get the chemicals from the earth abundant source, do the chemical modifications, and then we have this hybrid seeding agents. Okay, so then we perform some of that chemistry stuff, and ultimately we have that seeding agent that is the chemical that we're going to separate those clouds, which will cause it to rain because this chemical agent will act as a vapors. So limitations and risks. Yes, we have limitation and there are a lot of risks. So we are spraying the chemical onto this into the environment, and that will create environmental and health concerns because whatever the chemical it is, it's going to fall onto the ground. So, right, this is the normal salt that we consume in our food, in our whenever we cook something. The salt that we use is normally this sodium chloride. So just think about it that you put your salt on your trees and grass and crops. So it's not very helpful for them, right? So the rest of the salts and the chemicals are in the way of in the similar way. So whenever we separate these chemicals into the environment, they're going to come back to the ground, and we have to deal with that. And yes, it is very expensive, and we cannot just seed it once. May have to try it multiple times to ensure, yeah, that spray was good, accurate, so that spray was indeed on top of that cloud. So to have the maximum probability of success, we do have to repeat it again and again. And yes, it is indeed expensive. Not the chemical itself, it's not that much expensive, but the process is expensive because we have to bring the chemical to that near the clouds, and we need some kind of plane for that. And planes with flights are expensive stuff. So we do have limited effectiveness in these things. Okay, so 10 to 30% rainfall may increase from what it was going to naturally occur. Then we have this ethical and political dispute issue as well, because yeah, you can basically steal someone's brain as well. Yeah, China has been doing it to India. So China and India share a border, and there are a lot of clouds that go from China towards the India, and in the India, well, they are going to bring that rainfall. The water is going to be used by India for different purposes. So what China is sometimes do is this that well, before the clouds reach the Indian territory, they make it rain in their country. So basically, they are stealing their water. So if you make the rain from the clouds, well, the rain is already on the ground, so there is no clouds left. So you can, using this artificial rainfall, stop the clouds from going to some certain place. So yeah, that's unethical sometimes, and you may observe political disputes because of things like that. So yeah, there are different perspectives to this water technology. So yeah, it is what we are looking forward in the future works is that we are looking for eco-friendly condensation nuclei. So this condensation nuclei is the technical term for that seeding agent, which is that chemical that you are going to separate, which will act as a magnet. Okay, so we want that chemical to be at least eco-friendly. Okay, because it is going to come to the ground. So when it comes to the ground, it should act as a fertilizer for the crops. Okay, and well, it will act as a fertilizer to the crops, but it will not be good for the animals who will drink it, the humans who may drink it. So we have to look for the trade-off because it might be good for the crops, but bad for the animals. It might be good for the animals, bad for the crops. So we have to look for the chemical or the agent, something like that. That is eco-friendly from maximum point of view. So we must and we are looking towards this fertilizer-based compounds, which is this potassium, magnesium, sodium salts. So they can be used as fertilizer for the crops. And then we have different other kind of chemicals as well that are eco-friendly. And then nowadays we are following this dual purpose mission, which is this rainfall plus soil nutrients. So if you're going to make it rain and whatever you put into the clouds is going to come to the ground. So let's put something that is good for the ground. Okay, so it will rain as well as provide nutrients to the soil that it will follow. And we are looking for cost effective and sustainable methods. So if we have to do it again and again, then well, it should be cost effective, right? So we have this iron-based rainmaking, and they use those electric charges instead of chemical that I previously explained. Charges encourage water droplets to cluster, the clustering combining together, and we can deploy these electric shocks to those clouds using drones or ground ionizers. So UAE and UK experiments show promising results. They have conducted this ion-based winemaking method by giving electric shocks to the clouds, and the results are pretty bad. Nice. So yes, now as I explained you previously, that to increase the maximum probability of success, uh, we are going to look at this hybrid approach that will have this eco-friendly condensation nuclei, the seeding agent, the chemical that you want to put into the clouds, along with the electrical charges. Okay, it is more reliable than the single method. If the single method is that you only give the electric shock or you only give the chemical to the cloud. So if you use both of them, then yeah, it's more reliable. And we have high rainfall probability. And well, yeah, since we're going to use electrical charges, so we will have lower chemical footprint. So this is an example of that well, uh, hybrid technique. So we had this water vapors on the left side, the pointy end. There were a lot of water vapors. It was not raining. So what we do is that we introduce a condensation nuclei, which is this red dots. And due to this condensation nuclei, all of these blue dots, which were the water vapors, in this picture you can see they combine together. They are attracted towards this red dot, the condensation nuclei, the chemical that we put in. And because they are attracted to this point, then, well, yeah, that's a big water droplet and it can fall under the influence of the gravity. And we bring these drones, a swarming of drones, swarm of drones is a lot of drones all together. They spray that seeding agent, which is the condensate nuclei, along with they have that electronics mounted onto them that will generate those electrical shocks. So we can use the drones for electric shocks, for giving electric shocks to the clouds along with that uh, condensation nuclei, the chemical that we don't want to separate. So by giving these two things together, we have a manipulated state, and that will ultimately make the water go down under the influence of gravity. So that is the block diagram of how hybrid techniques can be used for artificial rainfall. Well, drones, as always, have a lot of job to do, and they do. They do perform a great job, and we need them for precise delivery of agents, and they are cost effective in comparison to that aeroplanes. And the swarming capability for large cloud coverage is essential because we need maximum area of the cloud to be given the electric shocks with or provide uh, that chemical support. So it is equipped with sensor like humidity, wind, temperature. So we do understand much better the state of that cloud, so that we understand. Okay, do we need more spray, more electric shocks, or is it good enough? What's the probability of rainfall now? So we do need those feedback, and the drones have those sensors. So yeah, they are good choice, and the safer and cheaper than the aircraft. So if we look at the global applications, well, China is using this large-scale rainfall to bring relief to the drought regions and haze control. UAE is using drone-based ionization, which is much, much safer, eco-friendly, but the probability is low in comparison to the hybrid approach, which and uses this drone-based ionization along with that chemical spray. So USA is using for snowpack enhancement in Colorado, hail suppression, and a lot of other purposes as well. Australia is using artificial rain for agriculture purposes. Indonesia is using it for flood prevention by seeding upstream clouds. Like I previously explained, that you can prevent the floods if you make it rain at different points, so they do not all of them together rain at some certain point. So you make it rain at separate instance in separate places. So it does have a lot of benefits, which is the drought relief at the spots, agriculture and food security. We have water for energy. We can use it for electrical power and stuff like that. We can control the fog, the hail suppression, and yeah, it's a strategic climate too. We may use it for our good purposes, which is we'll have to consider though as ethical and political concerns while using it for some strategy. So yes, we have some concerns. The chemical safety and accumulation is one of the most important points because whatever you put on the ground, on the clouds will come to the ground, and we may cause this ecosystem imbalance because if we make it rain a lot to one point, well, we are stealing someone's water, right? So maybe our neighbor country will face the drought. Uh, if the clouds were naturally going to that country and we use the water from those clouds, well, what's going to go to that country? Nothing, right? So yes, it is somewhat called rain theft across the border. And the long-term climate impacts are unknown. We do not understand that if we use the water that is not naturally allowed to use, we do not know how it will impact in 10, 20, 50 years, or maybe 100 years. So we do need some kind of governance for some global rules so that there is some check and balance on this method. So even though this artificial rainfall supports the UN Sustainable Development Goals, the SDGs. It provides clean water. It acts in accordance with the climate action. It can serve that zero hunger and it can produce sustainable cities. So market for weather modification is growing, and people are investing in this green tech seeding, which is environment friendly chemicals. And there is a lot of potential for startups in drones and AI business here. So tourism, agriculture, aviation sectors are all benefiting from these techniques. So in conclusion, artificial rainfall is a merging science and technology field. So we are moving from the silver iodide, the chemical in the past, the traditional technique, towards the drones and AI that we are using these days. And we are moving towards the eco-friendly hybrid methods for the future. So we can't control the sky fully, but we can guide the rain. So in perhaps the future of water security may fall from the clouds if we can learn to make it rain responsibly. So that's it for the presentation. Thank you, everyone. So we can move on to the question answer session. Dr. Lambert, are you there?
Sorry, I was muted. Let's go to the
Yeah.
chat questions first. We have a lot of questions. Thank you, by the way. I didn't realize I was muted there and I just started talking.
No.
So let's see. In Africa, some people drink rainwater. Since chemicals are used in this to induce the rain, are there safety concerns?
Yes, definitely. Like I told you, no chemical is safe for human beings. So yes, if it is artificial rainfall and chemical was used to produce rain, it's not good for your health. You can't drink it. Shouldn't drink it.
And are the risks of acid rain?
Yeah, acid rain is a bit different kind of phenomena, but yeah, if we use some chemical that is acidic in nature and can act as a condensation nuclei, yes, then it's going to produce acid rain. However, we now use normally the SARs, which are more alkaline behavior, anti-acids. So whatever we put onto the clouds, that matters for answering the acid rain or alkaline rain question. So we may face it. No, may not.
Yeah. So is there a difference between artificial and natural rain?
Yes, so natural rainfall is going to occur naturally when the clouds well combine together and water vapors are joined by I would say the kinetic energy, the natural, and artificial rainfall is that when the water vapors do not naturally combine to make a bigger water vapor, but we introduce some kind of chemical that acts as a magnet to bring those water vapors together. So yes, there is a difference.
But I would imagine in artificial rainfall, there's not a lot of that chemicals because you're seeding it with a little bit, and then once the rainfall begins to form, it kind of builds and accumulates upon itself.
Yeah, well, as you see in this picture, so there are a lot of water vapors, small water vapors. When we introduce these red dots, the condensation nuclei, the chemical, well, it is going to somehow look like this because that chemical is the magnet that will attach different water vapors to itself, which will drop to the ground. So if the cloud does not have a natural ability for those water vapors to combine together, it will not without the presence of that chemical. So if we do not have that chemical, it's not going to rain.
But once the rain begins to fall from the top of the cloud, it'll hit raindrops, water vapor droplets down below, and then increase in size without seeding.
Yeah, well, it can hit down below, but not sideways, no upward. So yeah, somewhat natural phenomena may help, but to begin with, it will not even start without introducing those chemicals.
So is the seeding on the top of the cloud or throughout the cloud?
Top of the cloud is the
Top of the
best.
cloud.
Like you just explained, when we have the top layer covered with the chemical, then the rest of the layers will follow.
Yeah. So there's not a lot of chemical in the rainwater.
There is.
There is.
Yeah, there is. Yeah, there.
Okay, so it's detectable.
Yeah, using
Um,
some instruments.
okay, there's a question here from Taban. If there are no white clouds and it is clear there are no clouds, well, is it possible to have cloud seeding? No, you already said that.
Yeah, no,
Um, what are the possibility to have rains without natural clouds? You already answered that. You need clouds.
we need cloud.
Do droughts become more serious despite artificial rains? I mean, can you actually create droughts by always seeding rainfall in one area and you're producing a drought in another area?
Definitely, we can, and yeah.
Um, so when you artificially create rain, can you estimate the volume of water that will precipitate to the earth?
Well, y- we may get a prediction on that by putting the necessary sensors onto the drones that will go into the cloud and getting a feedback, real-time feedback of how much concentration of waters is around. So we may give a rough guess onto the precipitation that will occur, but without those sensors, well, there's no guess that we because we do not know how much chemical is going to hit the right spots and how much it will rain. Using those sensors, we may be able to answer some.
And do you feel that artificial rainfall is in line with the Sustainable Development Goals of the United Nations?
Yes, yes, definitely. Like I introduced to use this slide. Let me go ahead. So it is aligned with the SDG 6, 13, 2, and 11.
Mhm.
So it is helping somewhat.
In the water cycle, is there any link between artificial rain and groundwater?
Yes, because the groundwater will naturally produce the water vapors that will go up to to the sky, which will make those clouds in the first place, which will be used for artificial rainfall.
And I guess the last question here from Rose is rain. So is this type of rain drinkable by humans, or should we be somehow trying to filter it before it gets to humans?
Well, we can't filter it before it gets to human because uh, between the cloud and the ground is not a lot of space that we can put some machinery on. So if it is cloud seeding based, then it's probably not going to be friendly to the humans. But if you are making it rain using the electric shocks only, then probably it's raining. It's safer to bring. But overall, I would say that if it is artificial rainfall, never bring it.
Do you know of cases where people are getting sick from that type of artificial rain?
Well, if there are, they've not been reported, but yes, this concern is highly, well, it exists, and I've not seen any reports, so
I
it
haven't
does exist,
either. I haven't seen any reports on health effects yet.
probably because of some political issues or whatsoever, the regions, but it may happen.
Okay,
It's
let's
just near
go
to.
to uh, Ismail. Keep the questions short because we only have about 10 minutes, and we have about three more questions to ask.
Okay, sir. Good morning, sir.
Good
Yeah, good
morning.
morning.
Good one.
Yes, sir. Good morning, Professor. Good morning, everyone. Yeah, here's the question. What potential, let me take it again. What potential ecological consequences might arise from widespread implementation of cloud seeding technologies? And how can aerospace engineers design drones to minimize this impact?
Well, the cloud seeding, the chemical agent can be weighed in a lab, and we can test it. Is it going to be environment friendly or not? All we have to do is that we have to bring that chemical on top of that clouds. So the drones are going to come back to the ground, so they're not going to impact in any way to the environment. So the drones should be just good enough so that they have the enough flight time, and they can go into the cloud with high humidity. The sensors and motors, they do not get affected by those water vapors, and they can go there, spray in a good manner, come back to the ground, and that's it. So engineers can look for those parameters while designing the drones.
Okay, thanks.
All right, now we go to Anne Marie. Go ahead and unmute your microphone.
Good morning, Dr. Lambert and presenter. I have two questions. From a political perspective, I'm anticipating that it may be easy to manipulate rainfall in areas of your enemies. So there's a increased chance of conflict. So the powers that have control, care and control of the technology, if they want to sabotage a region, they can do so via the rainfall. That is a possibility. Do you agree?
Yes, I'm looking at some slide. I think I didn't add it, but yes, it
Okay.
has been used in Vietnam War. Well, they made
Okay,
it
good.
artificial rainfall, and well, the soldiers were stuck because of the flood. They couldn't get the transport, no food, no uh, due to the flood. So yes, it is indeed. It can be used as a weapon as well.
It
You
can
can just put
also
some.
it can also be used to destabilize regions that depend on agriculture as well, if
de-
you want to sabotage
Definitely,
their economy.
definitely, it can be
And
used like that.
finally, how do we create international laws, and do you think international laws and policies are necessary to control the ethical aspect of this kind of technology? And finally, what
Yes,
impact does artificial rainfall potentially have on climate change, if any?
yeah.
Thank you.
So yes, yes, absolutely, it is absolutely necessary to have some international law because this kind of technology can affect a huge amount of people, countries, neighbor countries. They may well cause conflicts between the neighbor countries, and there should be laws regarding that. And what does it? How will it affect in the longer run? Well, we do not know because it is not being used very wisely, and yeah, we need 50, 60, 100 years to answer that. So we'll see. Our children will tell us.
Abdullah, go ahead. Activate your microphone so that you can ask your question. Abdullah. Okay, let's go to Abu Bakar. Abu Bakar, can you activate your microphone? Abdullah, either one of you. No? Nope.
may ma wax sama xaritu américain yi. Are you hearing me, teacher?
Yes, we can hear you now.
How are you? I'm rounding for my for a little bit. I'm I'm I was following. I was following the course. It's very interesting in the rainfall. Let me. Uh, I can say I'm congratulate all the teachers of AIU for for the for the course is very interesting rainfall because we are in a summer season It was raining, even raining a lot, raining. I remember a citation of a Greek citation in English: "Rain on the green grass, rain on the blackboard, but not on me." Whenever we was in the college school, whenever we were in a young boy, I remember the teacher was giving the citation for making the demonstration of the rain. It's important, but it destroys a lot of things. Here in Senegal, it's very hot, and we are in the summer season. People are receiving the rain as a clemency of the Lord. It is a clemency. Even it is destroy our habitation. It destroy some district. People are suffering from the rain. But the rainfall, the artificial rainfall, my question is, even it's very important for the agriculture, for the physiocracy. My question is, are you hearing me, teacher?
Yes, yes.
Yeah. My question is, Professor, the artificial rain, whenever people are using it, it is only in the film, in the movies, only in the movies, or sometimes people are using it in the how I can say, for
I got it in the real world, right?
creating
Got your question.
clouds. It is possible to create cloud for making artificial rain. The importance of the artificial rainfall. What is the important?
Yeah,
It is
yeah.
a two
So
ask.
I
It
got
is
your question.
the movies. Whenever
Thank
people are making movies, or thank you thank you.
Yeah, so yes, it has been used. I believe it was 1949, the first time that artificial rainfall was used. Now, in the recent years, it is being used. It's not in the movies only. It is being used throughout the world in different parts. UA is using a lot of it. So I did include, yeah. So UA is using for drone-based ionization. China is using it. America is using it. Australia, Indonesia, a lot of countries are using it. It was used in the Vietnam War. That's a lot older than today. So it is not in the movies only. Did I answer your question? Did I answer your question, sir?
waaye sëñ bi kay man xam naa ne xanaa rek doo ñëw ba ci hôpital bi ñu def fii ñëw fekk professionnel de santé
Okay, we can move to the next question.
Yeah, let's go to Olufemi because Olufemi has not asked the question yet. And then we'll go to Usman.
Can you hear me, sir? Thank you very much, my Professor Lambert. Can you hear me, sir?
Yes, we can hear you
Yes.
just perfectly.
Okay, thank you very much. Thank you, sir, Professor Mugeis. My question is, are there any international regulations in force or in place to prevent some terror organizations or terrorist organizations from leashing out acid rain on any particular area in order to terrorize the people? Because are there any international safety standards that are enforced to prevent acid rain? Can you hear me, sir?
Yes. So, yeah, well, artificial rainfall is not necessarily going to be acid rain, but yes, I believe there is something called a CLR tap. That's some kind of well, entity that is under the United Nations, that does control that actions regarding acid rain. So it does take some effect if there is someone who's using acid rain and people are getting affected. So it was established in 1979, so that's pretty old. And yes, it's not that like anyone can do the artificial rainfall. There are people who will ask you globally. So does that answer your question?
Thank you, sir. Thank you
Thank
very
you,
much.
Olufemi.
Thank you.
Okay, now we go to Usman. Go ahead and activate your microphone. Usman.
Hello.
Hello.
Yeah, how are
Hello.
you?
Good.
Great, sir.
Hello.
Hello. We are here.
Okay. You getting me?
Yes, perfectly.
Are you get? Oh yeah. Okay. I think that despite what I was thinking, that despite the artificial rains, food like rice or other vegetables are very rare in these worlds.